Okay, now for the Coulomb's law of electrostatic force, Coulomb's law. Force. Okay, 2-point charges. Q and Q prime, Q1 and Q2 are a distance r apart in vacuum. If Q1 and Q2 have the same sign, the two charges repel each other. If they have opposite signs, then they attract each other. The force experience by one charge due to the other is given by Coulomb's law. Coulomb's law. Where F is equal to K Q1 Q2 over R squared, where K is a positive constant, where K is a positive constant. Note that a positive F tends to increase R. In the SI, the unit charge of the Coulomb, to avoid very small numbers in practical work, the Micro Coulomb. Okay, we're using Micro Coulomb. 1 Micro Coulomb is equal to 1 times 10 to the negative 6 Coulomb, while 1 Nano Coulomb is equal to 1 times 10 to the negative 9 Coulomb. A constant value for K. Okay, we have again the formula. We have F is equal to K Q1 Q2 over R squared, where K is the positive constant. K is positive constant, which is equal to 9.0 times 10 to the 9 Newton meter squared per Coulomb squared. Okay. Another constant value for K, we have 8. We have 9.09, but that the original value is 8.988 times 10 to the 9 Newton meter squared per Coulomb squared. That is the reason we have 9 times 10 to the 9. We just round up it into a whole number. Now, if we're going to use F, in dyne. The unit is in dyne. And R in centimeter. And then the Q, yung charge, is in ECU. ESU. ESU is electrostatic. Electrostatic unit. Okay. Then, the conversion in Coulomb, 1 Coulomb. 1 Coulomb is equal to 3 times 10 to the 9 ESU. Okay. The fundamental smallest charge found in the nature is denoted E. Its value is 1.602. E is equal to 1.60219 times 10 to the negative 19 Coulomb. All other charges are integers, multiples of E. The electron has a charge negative E, which the proton charge is positive E. Now, okay. Then we have often K is replaced by, K is replaced by 1 over 4 pi EO. Okay, where O is equal to 8.85 times 10 to the negative 12 Coulomb squared per Newton meter squared. Okay, it's called the permittivity. This one is you call the permittivity. Permittivity of free space. Free space. In terms of the Coulomb law, becomes for the vacuum, we have F is equal to 1 over 4 pi permittivity of space times Q1, Q2 over R squared. Okay, in vector form, F2, the force on charge Q2 due to the charges Q1 is given by F2 is equal to K Q1 Q2 R over R cubed. Okay, where R is the vector displacement from Q1 to Q2. Kasi dapat this one is R. Okay, where R is the vector displacement. R is the vector displacement. Displacement from Q1 to Q2. And R is equal to, where R is the unit vector in the direction of R. Now, okay, we have the value for when the surrounding medium is not a vacuum, forces caused by induced charges in the material reduced the reduce the force between point charges. Okay. If the material has a dielectric constant, K, capital K, then permittivity of free space in Coulomb's law must be replaced by K equal to where E is the permittivity of the material. Then we have F is equal to Q1, Q2 over pi E 4 pi E R squared, with permittivity of materials is equal to K E O. For vacuum, K is equal to 1 for vacuum. And for air, K is equal to 1.0006 for air. And is thus often taken to be 1. Okay, sometimes we're using just only 1 for the air. Example. How many electrons? How many electrons are contained in -2 Coulomb of charge? What is the total mass of these electrons? Okay, now, remember that the electron has a charge negative electron. Okay, where E is equal to 1.6 times 10 to the negative 19 Coulomb. Therefore, in -2 Coulomb of charge, there are N is equal to 2, which is 2, divided by 1.6 times 10 to the negative 19. Okay, therefore, this one is equal to what? Okay, therefore, this one is equal to 1.25 times 10 to the 19 electrons. Now, the mass of these many electrons, we have M, which is M is equal to N times M, mass of electrons. Okay. We have the value of N, which is 1.25 times 10 to the 19 multiplied by the mass of electron is 9.11 times 10 to the negative 31 kilogram. Okay, therefore the mass is equal to 1.14 times 10 to the negative 11 kilogram. Electrons, how many electrons? This one. Okay, example number 2. If 2 okay, if two equal charges, each of 2 coulomb were separated in air by a distance of 1.5 kilometers, what would be the forces? What would be the force between them? A formula, we have F is equal to K Q1 Q2 over R squared. Okay, we have your K, which is 9 times 10 to the 9 Newton meters squared per coulomb squared, multiplied by 2 coulombs, Q1 and Q2 is 2 coulombs, divided by R, which is 1.5 kilometers, times 1 kilometer is equal to 1,000 meter. Cancel, kilometer. F is equal to, this one is R squared. Okay, where F now is equal to 16,000 newtons, or that is also equal to 16 kilonewtons. Kilo is times 10 to the 3. Okay, another example. Number 3. Number 3 example. Okay, 2 electrons. 2 electrons in a vacuum experience a force of 2 times 10 to the negative 15 newtons. How far apart are the electrons? Using the formula F is equal to K Q1 Q2 over R squared. Since the requirement is the distance, therefore you are required to find for R. Okay. You have your R is equal to square root of K Q1 Q2 over R squared. The given is 2 electrons, therefore equal to square root. K is 9 times 10 to the 9 Newton meter squared per coulomb squared. Okay, for the electron, we have the value for the charge of electron, which is 1.6, 1.602117 times 10 to the negative 19, since 2 electrons. Therefore, this one is squared, Q1 for Q1 and Q2 over, this one is F. This one is F not R squared F. The force of 2 times 10 to the negative 15 newtons. This one is in Coulomb squared. Coulomb squared, cancel, cancel, Newton, Newton. R now is equal to, okay, R now is equal to 3.4 times 10 to the negative 7 meter.